Okay, so today I told you we're the doctors. So today we are talking about what's a reciprocal function, and you have your notes. You should have your notes out, take your notes. So first we got to go over a few definitions. We know we have SOHCAHTOA, our three basic trig functions. Okay, our three basic trig functions, which we've been working with for the last, since before break, and that is sine, cosine, and tangent. And those are on your calculator, or those ratios and everything. Well, there are also three reciprocal trig functions, reciprocals of these. And so the reciprocal of sine would be 1 over sine. I'm going to use theta for my angle. So 1 over sine theta, and we need to give that a name. And so the name for 1 over sine theta is cosecant theta. Okay? And the abbreviation for that is CSC theta. So cosecant, CSC, cosecant is the reciprocal. The reciprocal of cosine, I'll write this up here first, is called secant, and the reciprocal of tangent is called cotangent. Okay? So that means that cosecant of theta would be equal to whatever 1 over sine theta is. And secant of theta would be equal to 1 over cosine theta. That piece you have to memorize. You've got to know which one goes with which. You can remember it by cosine backwards. Kind of looks like SEC. It's SOC, so it's like secant, and then sine would just be the reverse. Most people remember tangent and cotangent. They kind of fit together. So cotan, abbreviation COT, of theta would be the same as 1 over tan theta. Okay, so those are straight up definitions that you need to remember. However, this version of it is not always the most helpful, like in a picture. So if you think about it, you know that sine of any angle is equal to opposite over hypotenuse. Okay, so if sine of theta is equal to opposite over hypotenuse, and we know cosecant is the reciprocal of that, reciprocal means flip, right? So that means the cosecant of theta would also not only be equal to 1 over sine theta, but would also be equal to hypotenuse over opposite, right? A flipped version of that. Same for this one. I know that cosine of any angle is equal to adjacent over hypotenuse. So secant is the reciprocal, which is 1 over cosine, which means you could also say secant of theta is equal to hypotenuse over adjacent. Okay, and same, tangent theta, SOHCAHTOA, is equal to opposite over adjacent. So therefore, cotangent is 1 over tangent, or cotangent of theta would be the same thing as adjacent over opposite. So depending on what you're trying to do, depends on what scenario you might want to use, or what definition, or what version you want to use of this. Okay, so let's just try some examples. These are definitions, you've got to memorize them, you've got to know what goes with what. Okay, so in this first one it says, in a right triangle, angle A is an acute angle, and the tan A is equal to 5 over 3. Find the value of cosecant A. All right, well you should now draw a picture. You know you have a right triangle. Since we're doing the tan of A, you know that angle A is an acute angle, because we can only use acute angles for this year. Okay, so angle A, let's say I put it here. And I also know from this, because I know tan is equal to opposite over adjacent, that means that since we're going off of angle A, the opposite side would have to be 5, and the adjacent side would have to be 3. So I can get all of that from this information to draw my picture. Okay? Now, what do I want to find? I want to find cosecant of A. Okay, so the part I have to memorize. Cosecant is the same thing as 1 over sine of A. Or cosecant of A would be the same thing as, since sine is opposite over hypotenuse, it would be hypotenuse over opposite. In this case, I'd say it's probably easiest to use this because I got a picture and I could figure out what the hypotenuse is. And I would do that with Pythagorean theorem. So a squared plus b squared equals c squared, or 5 squared plus 3 squared equals c squared. 25 and 9 gives me 34 equals c squared. So c is equal to the square root of 34. Get rid of the negative because you're dealing with length. Okay, so here's my picture. I now have everything that I need to answer this question. If I want to go secant of a, then, final answer, cosecant of a, not secant, cosecant, would equal hypotenuse, which is radical 34, over opposite, which is 5. And that would be my final answer. All right. What about more specifically, secant of 60? Okay, so I know what they're telling me here, since I'm looking for 60, is I have to have a right triangle, because I'm dealing with trig. One of the angles has to be 60. Oh, so that means this is really a 30, 60, 90. And I know that the side opposite 30 is x, the side opposite 60 is x radical 3, and the side opposite, or the hypotenuse, is 2x. I also know, what else do I want to know? I also know that secant of any angle, so let's say secant of theta, is the same as 1 over cos theta, or I also know that secant of theta is equal to the reciprocal of cosine, so hypotenuse over adjacent. Again, since I have a picture, this is probably the better deal for me, right? So secant of 60, not theta, because I know what theta is in my picture, secant of 60, which is the answer I'm looking for, would be equal to hypotenuse, which is 2x, over adjacent to the 60, which is x, and then I could simplify that, and I know that the secant of 60 will always be 2. X's cancel out. So secant of 60 is 2. Okay, I could do the same thing here. Cotangent, I can draw a picture of that. And I'll make this my 30-degree angle. And I know 30, 60, 90, this is x radical 3, and this is 2x. It's cotangent, so what do I know? Well, I know that cotangent of theta, these are a piece I have to memorize, is 1 over tan theta, or cotangent of theta then, this tangent is normally opposite over adjacent, which means cotan would be adjacent over opposite. Again, I have a picture, so this is probably the best for me here. So cotangent, based off that, cotangent of 30 would have to be the adjacent side, which is x radical 3, over the opposite side, which is x. The x's cancel out. And cotangent of 30 then is equal to radical 3. Can do the same thing here. It's a 45, 45. Special, right? So 45, 45 means x radical 2, all that old stuff. I am looking for cosecant. So things I need to think about. Cosecant of theta is equal to 1 over sine theta. Or cosecant of theta, no matter what the angle was, would be the reciprocal of sine. So hypotenuse over opposite. Again, I would pick this because I got a picture and it's easy to base everything off of. So the cosecant of 45 equals my hypotenuse, which is x radical 2, over the side opposite, which is x. X's cancel out. Cosecant of 45 will always equal radical 2. Final answer. All right. Okay, again, you always want to draw pictures. So given triangle KM, where K is a right angle. Okay, so you got a right triangle, got to read and draw. K is my right angle, doesn't matter where I and M go. Now, lowercase I means side opposite angle of the capital letter I. Like when you do Pythagorean theorem, lowercase a, lowercase b, lowercase c, technically are opposite a's, b's, and c's. Okay? So that's where that comes from. So I know when it says lowercase I, that I go to angle I, and I go opposite, and so therefore 8 would be km. And opposite little k then would be opposite k, which is my 90-degree angle, which means 14 is actually my hypotenuse. Okay, so you got to know how they represent different things in the problem. And they're just looking for what the tan of m is going to equal? Okay, so tan of m. So I find m, here's m, and I want to know what the tan of m is going to be. Okay, well that's going to be opposite over adjacent, no reciprocal functions here. Not worried about reciprocal functions. But I don't have the opposite side, I have the adjacent side, so I know it's over 8, but I need to find this. So what do I have to do? Pythagorean theorem. So a squared plus b squared equals c squared. So 8 squared plus b squared equals 14 squared. 64 plus 196, sorry, plus b squared equals 196. Bring my 64 over, b squared equals 132. Square root, b equals the square root of 132. So that's this. Get rid of the negative. Square root 132 on top. And that's all they were looking for? Tan of m. Okay. Now, the directions are find the value of the 6 trig functions. Okay, so the 6 trig functions. And we're using angle G here in this case. So I circle G. And I got all the sides. Okay, well, what are the 6 trig functions? Well, we want to find the basic ones, sine of G, cosine of G, and tan of G. Those are the basic 3 that we know. Tan, so katoa. So sine, okay, take G, I need the opposite side, which is radical 7, over the hypotenuse, which is 4. Done, there's sine. Cosine of G, I need the adjacent side, which is 3, over the hypotenuse, which is 4. Tan of G, I need the opposite side, radical 3, oops, sorry, radical 7, over the adjacent side, which is 3. Okay, so those are easy ones, those are ones we've been doing all along. What are the other 3? The other 3 are the reciprocals. So the reciprocal of sine is cosecant, okay, so cosecant G. And what do I know about cosecant? It's the reciprocal of this, so flip them, you already know what it is. That makes it 4 over radical 7. However, can we leave a radical in the denominator? No. So what do we have to do? Same stuff we've done before, rationalize. Multiply top and bottom by radical 7. So cosecant of G is actually 4 radical 7 over 7. Final answer. So here's my sine of G, here's my cosine, this is my answer, this is my answer. Final answer here, 4 radical 7 over 7. All right, what is the reciprocal of cosine? The reciprocal of cosine is secant. So I'm doing the secant of G. What do I have to do? Flip it, reciprocal. Okay, so 4 over 3. Don't need to simplify. Done. There's the secant of G. All right, and the reciprocal of tangent would be the 6th trig function, would be cotangent of G. Again, flip it. That would be 3 over radical 7. Can't leave it. Multiply top and bottom by radical 7. Cotan of G then is equal to 3 radical 7 over 7. Final answer. And that's all they were looking for there, the 6 trig functions. All right, one more and then you're going to work on your homework. So you're looking for the 6 trig functions again, and you're also looking for the degree measure of theta. All right, well, what's the key? I know the lengths of the sides. This is 3. This is 4. Probably going to need to find this other one. So if you remember the Pythagorean triple, you know it's going to be 5. But in case you don't remember that, you would do Pythagorean theorem to find the hypotenuse. So 3 squared plus 4 squared equals c squared. 25 equals c squared. C would equal square root of 25. So c would be 5. Got it. Okay, and we just went over the 6 trig functions, right? So the first one, sine of theta. Okay, so here's theta. So sine of theta would be equal to opposite over hypotenuse. No need to simplify, no radicals. Number 2, cosine theta. Okay, well cosine theta would be adjacent over hypotenuse. Third one, tan theta. So tan theta would be equal to opposite over adjacent. Okay, easy enough? All right, fourth one, reciprocal of sine. So again, gotta memorize. Reciprocal is cosecant of theta, and that's equal to the reciprocal. So 5 over 4. Cosine of theta is equal to, or the reciprocal is equal to secant of theta, and that's reciprocal again, so 5 over 3. And reciprocal of tangent is cotangent, and so that would be equal to 3 over 4. Okay, so those are pretty easy. Last piece they ask us to do is find what angle theta is. So you have options because you got all these things. A 4, 5, and 6 not helping me because I don't have any key on my calculator for those. But I could do any of these and find the angle that I want, right? What do I have to do? Let's do what we did yesterday, inverse, okay? So I could say, okay, let's find theta by doing the inverse sine of 4/5. Okay, then I go to my calculator, make sure I'm in degrees. They told me to round to the nearest degree, so when you type that in, you should be getting 53 degrees. Final answer. Those are all your answers. But double check. I mean, if you do the inverse of cos, so cos inverse of 3/5, you should also get the same theta. Same answer. Or if you did inverse tan of 4/3, you should also get the same theta. It's not going to matter which one you use. Those ratios are the same. Okay, so that's your reciprocal. If you need to go back and listen to the video again, if I went too fast or you got lost anywhere, maybe go back and watch one of the examples again. Otherwise, you are working on your homework. Okay, and make sure you understand it. And any questions you had on last night's homework and or this homework, I will go over either after school, because I'm here today after school, or tomorrow in class. All right. See ya.